A fully loaded ship glides into a stone dock completed almost 180 years ago. Moments later, the water begins disappearing, leaving thousands of tons of steel resting safely on dry ground. Nothing about the process looks outdated. That's what continues surprising engineers today. This remarkable structure was designed long before electric pumps, hydraulic machinery, or computer models existed, yet it still performs the same essential job with astonishing reliability. How did 19th century builders create something that refuses to become obsolete? Before we uncover the answer, tell us where you're watching from, and let's step back to where this extraordinary story first began. The story begins during a period when international trade was expanding faster than ports could keep up. Merchant fleets were growing larger, naval vessels carried heavier equipment, and ships remained at sea for much longer than ever before. Every successful voyage brought another problem back to shore. Hulls needed repairs, rudders cracked, copper sheathing wore away, barnacles slowed every journey. Finding a safe place to fix those problems had become one of the greatest challenges facing maritime nations. Most repairs happened the difficult way. Crews waited for favorable tides, pulled smaller vessels onto wooden slips, or worked from unstable platforms built beside the shoreline. Larger ships rarely had that luxury. Their size alone made routine maintenance slow, expensive, and sometimes impossible without dismantling major sections before any repairs could even begin. As commercial competition increased, delays became costly. A damaged vessel sitting idle earned nothing while valuable cargo waited for transport. Naval ships faced an even greater concern. Every week spent in repair reduced a nation's ability to protect trade routes or respond during conflict. Harbour authorities realized the problem could no longer be solved with temporary solutions. Attention gradually turned toward an idea that sounded almost unbelievable for its time. Instead of adapting repairs to changing tides, why not create a permanent enclosure where the water itself could be controlled? Ships could enter while floating normally, the entrance could be sealed, and the water removed whenever maintenance became necessary. Once repairs finished, the basin could simply fill again before the vessel sailed away. On paper, the proposal seemed straightforward. Reality proved far more demanding. Such a dock would have to survive constant pressure from surrounding water, support the tremendous weight of fully loaded ships, and operate reliably through changing seasons year after year. Any weakness hidden inside the structure could threaten not only the dock but every vessel using it. Location quickly became another difficult decision. Engineers searched for ground close enough to existing harbours, while remaining stable enough to support an enormous stone enclosure. Access for ships mattered just as much as the strength of the underlying ground. A poor location could turn an ambitious project into a permanent failure before construction even started. Governments understood the financial risk immediately. The investment would be enormous, construction would take years, and success remained uncertain. Even so, the potential reward outweighed every concern. A permanent dock promised faster repairs, longer ship lifespans, stronger naval readiness, and increased commercial activity for generations. Approval finally arrived, and survey teams marked the future construction site. From that moment forward, the project stopped being an ambitious proposal and became one of the boldest engineering undertakings of its era. The greatest obstacle, however, had not been solved. Choosing the location was only the beginning. Before a single permanent wall could rise, builders first had to create a dry workplace in a place where the sea returned twice every day, exactly as nature intended. The drawings were complete, the funding had been approved, and the site had been chosen. Now the builders faced an opponent that ignored schedules, ignored deadlines, and arrived with every incoming tide. Survey stakes now marked the future dock, but the ground remained underwater for part of every day. Before any permanent structure could exist, the builders had to claim enough space from the sea to work safely. That challenge demanded careful planning long before the first block of stone ever reached the site. If you're enjoying this journey into forgotten engineering, consider subscribing, because the next stage reveals one of the smartest construction strategies of the 19th century. Work began with temporary barriers built around the selected area. Timber piles were driven deep into the seabed, forming a protective enclosure strong enough to slow incoming water. Clay, gravel, and compacted earth filled the spaces between those rows, creating a barrier that reduced the force of each rising tide. It wasn't perfect, but it gave the crews something they had never possessed before, a fighting chance. Water still found its way inside. Small leaks appeared through weak joints beneath the barrier and around uneven ground. Instead of treating every leak as a disaster, the crews expected them. Men worked continuously with hand-operated pumps, buckets and drainage channels, removing water almost as quickly as it entered. Progress depended on persistence rather than speed. Conditions changed constantly beneath their feet. Soft mud could not support heavy masonry, so unstable material had to be removed layer by layer until firmer ground appeared below. In some places, workers dug much deeper than expected before reaching material capable of carrying the enormous loads the finished dock would eventually bear. Every measurement mattered during this stage. Surveyors checked depths, slopes, and alignment repeatedly because small errors at ground level would multiply as construction continued upward. Their instruments looked simple by today's standards, yet they provided the accuracy needed to guide one of the largest maritime projects of the era. Weather refused to cooperate. Powerful storms damaged temporary barriers, while unusually high tides flooded areas that had already been cleared. Strong winds delayed deliveries, and heavy rain turned freshly excavated ground into deep mud. Each setback forced the crews to repair damage before moving forward again, extending a project that already demanded extraordinary patience. Slowly, the site began changing shape. What had once been open shoreline became an enormous excavation surrounded by temporary defences. Wagons carried away spoil, fresh materials arrived every day, and organised teams moved according to carefully planned schedules instead of reacting to constant emergencies. For the first time, the future dock became visible. Months of preparation produced a space that looked surprisingly ordinary. Visitors saw little more than a vast empty basin cut into the ground. They could not see the planning hidden beneath it, nor the countless decisions that had made the next stage possible. With water finally pushed aside, construction could begin in earnest. The empty excavation was no longer the goal. It had climbed 638 time to serve ships for generations. The sea had been held back long enough to begin building. What rose inside that dry basin would explain why this dock continues astonishing engineers nearly 2 centuries after the final stone was placed. With the excavation complete, the builders could finally begin creating the dock itself. This stage demanded far more than stacking stone into tall walls. Every decision had to account for forces that would act on the structure every single day for generations. Water, changing tides, shifting ground, and the tremendous weight of visiting ships all had to remain in balance. Construction started at the lowest point of the basin. Large foundation stones were placed directly onto carefully prepared ground, forming a stable platform beneath the entire structure. These blocks were chosen not only for their size but also for their strength. Cracked or uneven pieces were rejected because weaknesses hidden at the base could threaten everything built above them. Instead of relying on mortar alone, masons shaped neighbouring stones so they locked together naturally. Each block supported those around it, spreading pressure across the structure instead of concentrating stress in a single location. That approach reduced movement over time and helped the dock withstand countless cycles of loading and unloading. The walls followed another carefully considered design. They did not rise as perfectly vertical surfaces from bottom to top. Their thickness and profile changed gradually, allowing them to resist pressure more effectively while using materials efficiently. Engineers understood that stability depended on geometry just as much as mass. Water also played an unexpected role inside the design. Small drainage passages were incorporated where necessary to relieve unwanted pressure building behind sections of masonry. Rather than trapping moisture inside the structure, the builders allowed it to escape in controlled ways. That simple decision reduced long-term damage and protected the walls from hidden stress. Material selection received equal attention. Dense granite formed the primary structure because it resisted abrasion, absorbed little water, and tolerated repeated exposure to harsh marine conditions. Hydraulic lime mortar bonded the masonry while continuing to perform even in damp environments. Together, those materials created a structure able to endure conditions that quickly destroyed ordinary construction. Nothing reached the site without inspection. Surveyors verified dimensions before installation, while master masons checked alignment continuously as each course progressed. Adjustments happened immediately whenever tiny differences appeared. Correcting small mistakes during construction proved far easier than repairing major failures decades later. As the walls climbed higher, the shape of the dock became unmistakable. Wide stepped sides provided access for workers maintaining ships below the waterline. Strong coping stones protected the upper edges from repeated impacts, while carefully positioned mooring points allowed vessels to remain secure during every stage of repair. By the time the final sections were completed, the dock looked surprisingly simple. That appearance hid an extraordinary amount of engineering thought. Visitors noticed massive stone walls. Engineers recognized carefully balanced forces working together beneath every visible surface. One final challenge still remained. A dry dock existed for only one purpose: receiving ships, emptying safely, and returning them to the water without damage. Achieving that routine repeatedly required an operating system just as intelligent as the structure surrounding it. The stonework had passed its greatest test by standing firm. The next question was whether the dock could perform its remarkable task smoothly every time another giant vessel crossed its entrance. Completing the masonry did not mean the dock was ready for use. Empty walls and solid foundations solved only part of the problem. The real purpose of the structure was to receive a full-sized ship, remove the surrounding water without disturbing its balance, and return that vessel safely to the harbour after repairs were finished. Every operation followed a carefully planned sequence. The process always began while the basin remained completely flooded. Water inside the dock matched the level outside, allowing a ship to sail through the entrance under its own control. Harbour pilots guided the vessel slowly toward a precise stopping point marked long before the captain could see it from the deck. Dock workers then secured thick mooring lines from several directions. Their task was not simply to stop movement, but to hold the ship exactly where engineers intended. A small shift during the next stage could place enormous pressure on the hull once the water level started falling. Hidden beneath the surface waited dozens of timber keel blocks arranged along the center of the basin. Their positions had been calculated to match the shape of visiting vessels. Adjustable side supports stood ready nearby, prepared to steady the hull as its weight gradually transferred from water onto the dock below. Once every inspection was complete, the entrance gate closed. Instead of rushing the operation, crews checked every seal before removing a single gallon of water. Patience prevented costly mistakes because correcting an error after pumping began was far more difficult than delaying the schedule for another inspection. Powerful pumping equipment then started lowering the water level. Early installations relied on steam-driven pumps, while gravity assisted wherever the design allowed. The change happened slowly enough for supervisors to monitor the ship's position throughout the entire operation. Nothing was left to chance. As the water disappeared, the hull settled gently onto the waiting keel blocks. Side supports made contact one after another, keeping the vessel upright while preventing unwanted movement. Every crew member understood that balance mattered more than speed. A successful docking looked almost effortless because each stage had been rehearsed countless times. Hours later, the basin stood almost completely dry. Workers who had been sailing aboard the ship that morning could now walk beneath it, examining damaged planks, replacing worn metal plates, repairing rudders, or cleaning marine growth from areas normally hidden below the waterline. Jobs that once demanded weeks of preparation could finally begin within a controlled environment. After maintenance ended, the sequence unfolded in reverse. Water returned gradually. The hull floated free from its supports, the gate reopened, and the restored vessel sailed back into the harbour ready for another voyage. The dock immediately prepared for its next arrival, repeating the same process with remarkable consistency. From the shoreline, the entire operation appeared surprisingly calm. Behind that calm routine stood years of planning, careful calculations, disciplined crews, and a system that transformed one of maritime engineering's greatest challenges into an organized daily procedure. The dock handled one ship after another with impressive reliability. Its greatest achievement, however, was not a single successful operation. It was continuing to perform that same sequence decade after decade, despite constant exposure to the sea. Launching the first repaired ship proved the design worked. Keeping that success alive through decades of constant use became the greater achievement. Salt water never stopped attacking the stone. Heavy vessels continued pressing against the structure. Changing tides repeated the same cycle thousands of times. Even the strongest dock could not survive such conditions without careful attention. Harbour officials understood that small defects rarely stayed small for long. Regular inspections became part of everyday operation. Workers walked the walls after severe storms, checked joints for movement, examined drainage passages, and searched for early signs of wear before minor damage developed into expensive repairs. Water management remained one of the highest priorities. Drainage channels had to stay clear so trapped moisture could escape instead of building pressure inside the masonry. Silt, broken debris, and marine growth were removed whenever they threatened the dock's ability to function exactly as intended. Preventive work always cost less than rebuilding damaged sections later. The entrance gate demanded equal attention. Hinges, seals, locking mechanisms, and supporting timbers faced constant exposure to moving water. Skilled maintenance crews cleaned, adjusted, and repaired those components on a regular schedule because even a small leak could interrupt dock operations or place unnecessary strain on the pumping system. Stone itself also received careful observation. Most blocks remained remarkably stable, yet natural weathering slowly affected exposed surfaces. Rather than replacing large areas unnecessarily, experienced masons repaired only the locations that truly needed attention. Matching new stone with old masonry required considerable knowledge, ensuring repairs blended seamlessly with the original construction. Engineers recorded everything. Measurements taken years apart revealed whether walls had shifted, settled, or remained unchanged. Those records allowed future generations to compare conditions across decades instead of relying on memory alone. Decisions became evidence-based rather than guesswork. As technology advanced, new equipment gradually entered the dock without changing its original purpose. Improved pumps increased efficiency. Better lifting gear accelerated repairs. Modern inspection techniques revealed hidden details inside the masonry. Despite those improvements, the 19th century structure continued providing the same dependable foundation it always had. Visitors often assumed the dock survived because it was massively built. Size certainly helped, but thoughtful planning mattered far more. Water pressure had been anticipated. Drainage had been considered. Materials had been selected for the environment they would face. Maintenance had never been treated as an afterthought. Those choices worked together year after year. Many similar facilities disappeared because they adapted too slowly, suffered neglect, or faced changing commercial demands. This dock followed a different path. It evolved when necessary while preserving the features that had made it successful from the beginning. That balance between preservation and improvement became one of its greatest strengths. Nearly 2 centuries after construction began, ships still entered the basin, repairs still took place, and the stone walls still carried out the task they had been designed to perform. Few engineering works remain useful for so long without losing their original purpose. Time tested every decision hidden inside the dock. The final chapter explains why those decisions continue attracting attention from engineers who design some of the world's most advanced waterfront projects today. Some structures become famous because they look impressive. Others earn lasting respect because they never stop working. This 180-year-old dock belongs in the second category. If you enjoy discovering forgotten engineering stories that still shape our world, subscribe and join us for the next remarkable journey through history.